eSOL is a Japanese company headquartered in Tokyo. The company is providing engineering services and embedded products, mainly a real-time OS called MCOS POSIX and a hypervisor, and specialized in the embedded space. We can develop device drivers for our customers. We can help them to design and architect the software running on their embedded platform. We service the large part of the embedded platforms, including consumer devices, industrial, railway, medical, etc. And we have a specific expertise in the domain of ROS, which is helping for robotics, for example. We need to ensure the quality and the safety and the security of our products for our customer applications. To do that, we have the typical V-cycle development to follow, which means that we need to specify our software and then we need to verify that what we specified is the same. As this V-cycle verification and testing goes on, of course we need to test everything on the target, but we also need to verify and ensure that the functional safety requirement and everything is going according to plan. And this is a key aspect which is a challenge because demonstrating that we tested enough is very challenging. So the problem with verification is that it is always specific to a physical target that you test on, but sometimes you want to make a more generic claim. You need to, for example, test that your software is valid for all combinations, and making that more generic, absolute claim is very difficult. So sometimes instead of testing on the target, we resort to simulation, and the simulation environment allows to insert faults and so on. And this is where TrustInSoft can come into play. One of them is that we don't need a target. It is a mathematical simulation environment that allows us to run the unit tests that we have to verify that the functionality that we specified is indeed working. Then a second part of that, but it's just an extension really, is that we can run it in the cloud or we can run it on our servers independently from any constraint. Because this is one of the key aspects, key constraint of embedded software. At some point, it runs on a physical system. So at the end of it, even though we use TrustInSoft, we still have to test on the physical target. The last part of it is that the TrustInSoft tool brings, or at least they claim, and we follow it, and so far we see it, an absolute proof that the software is going to work as intended. So if our tests are well made, and we verify the output correctly, then we have a very strong claim that the software is running correctly, both from a safety and a security perspective. These tools will always require that you actually run on a specific target. So when you want to test, you test in a specific context, which means you restrict the verification to that specific context. TrustInSoft is, to our knowledge, the only tool that can allow you to provide this theoretical testing, the mathematical guarantee that you can define also the correct code, undefined behavior in the common language of the C and C++ and so on, and the abstraction from the hardware. Before we signed with TrustInSoft, we actually tried their software because the claim that they make is so strong that we had to test it. And they accommodated that very well. They were happy to prove that their software is doing what they claim they do. After signature, we also used their services to help us bring the software faster into our development lifecycle. The first one is to go faster, because when you test independently from the hardware, then suddenly all your developers can work on creating or verifying the test automatically. So now we run our test suite in the CI, on our servers, in a much more easy way and faster way, because before that we had to run on physical boards, which was always a physical limitation. Also enables us to do more extended testing, because One of the elements that the TrustInSoft tool can do is it doesn't have to do tests on one case, but it can do a test on a range of cases. So again, from a safety perspective, it's useful. From a security perspective, it's really great because now we can try to give to our software any random input. To other companies who are in the same space as eSOL, meaning the embedded space, I would tell them that it will save them a huge amount of effort to reach functional safety certification or security proof, or just getting their software to market faster because the testing becomes more widespread in fewer tests. And I think this is a really great asset, a really great thing that the tool can bring. The tool can help us at the unit test level, at the low level, and making the report and giving also code coverage. The tool evolved so that now we can do MCDC coverage with the tool that can be used for providing to our safety assessor evidence for the safety certification, which is great. The integration test and the system test to verify that everything is working correctly in the integrated system, we still do on the physical target. But everything else at the component level and at the daily life of software development can be done using the tool in the CI.